Sorry, I think I'm gonna have husky voice, so I apologize at the start. Um, Thank you for the introduction, Mike. So as what Mike said, I currently working as a data actuary in the data analytics team at Imagery. So we are a team of 7 people, mainly coming from actuarial, data science, geospatial, and financial analysis background. So I'm not a data scientist. So if you ask me any technical machine learning questions, I just have to say I'll get back to you. So location intelligence, what does it really mean? If you search this in the internet, you probably going to get different definitions from different sources. I want you to just think about the property that you're currently living in. Think about the process that you went through before you made a decision of purchasing it or renting it. You probably went through real estate agent website, filter out the postcode or suburb of your interest, checking out the property details, the price, how many bedrooms, the neighborhood, the proximity to transport or cafes. You probably call agent for more questions, go for inspection and search for external reports if you are purchasing it about historical prices. So that is an application of location intelligence. So now think about if you are a property pricing actuary. You might be thinking about what are the current gaps, what are the limitations of my pricing model. Do I need to collect extra locational data to help just to get that gap, to get more accurate assessment on the risk on the location property? So if you are a property portfolio manager, then you'll be concerned about the exposure concentration. So you might be asking your team to give you postcode mix of your exposure just to make sure you're not overly concentrated in a particular nat cat prone area. So all of these are applications of location intelligence. The point I want to make is location intelligence is not just about an address, not just about a geocoding, it's the context you put through it. It's the ability to generate insights that ties to the location. So why does it matter? We are in the insurance business, in the business of risk. Of course, risk assessment, better risk assessment and management matters, especially in the face of climate change and the Northern Queensland issues. More acute and precise risk understanding matters. So location intelligence is not new in the insurance industry. It's not a new concept. Insurers went through various channels to collect all different sources about the risk that they're taking. They're starting from the data they collect from the customer, just the basic questions about location, property feature, what is it used for, and then they merge with external locational data just to get more granularity view of the risk that they're taking. With the advancement of the technology and the digital connectedness, of course, some of them can actually tap into the digital data, like satellite imagery, aerial imagery, and Internet of Things devices. And of course, the big data, the untapped data sources, whatever that is not listed here, can be any shape or form. So the ability to access and analyze various
having those agile
data sets in a cost-effective way gives the insurer a competitive advantage. Do you really think so? If every insurer is doing the same thing, is it really a competitive advantage? Okay, so in order to maximize the use of your locational data or the use of all the data that you've got, so a good starting place would be looking at all the levers the insurers can pull. So where the decisions are being made. Before I do that, You got product development, distribution, underwriting, pricing, and the risk management, and of course the claims. They are all primary means of how insurers can manage or pull to achieve their objectives. So in my presentation today, I'll focus on two use cases, which will help answer the two questions. How to pay claims quicker and more accurately after an event. And also in the risk management side, how to geospatially visualize and understand my portfolio's exposure concentration. So I bring here the case one called remote sensing solution. The objective of this case is to improve the efficiency of claims handling process post a cat event. It was done through the collaboration of GIC and Imagery. I'll show you a YouTube video here, hopefully it works, about GIC. So basically, GIC stands for Geospatial Intelligence Center, a non-for-profit initiative from National Insurance Crime Bureau from US. They operate as a consortium of insurers. So what they do is they collect aerial imageries, both pre-CAT and post-CAT event for the insurer members. So the Imagery's role here, so Imagery is a member of GIC, and they're also an analytics partner. There's a team in Imagery in Munich, which consists of 20 people, with experts coming from data science, claims adjustment, geospatial, information management. And then, so the case basically, it was done between the two parties. So here I'm just showing some imagery, the aerial imageries, both pre and post-CAT, post-Hurricane Michael. So the point I want to stress out here is the ultra high resolution imageries, which is a 7.5 centimeter per pixel resolution. Basically, the lower the centimeter per pixel, the higher the resolution. And the turnaround, so when they send the fleet up on the sky annually pre-CAT, there's a 24 hours turnaround from the time the plane lands. They actually process it and then geocode it so the insurer members can actually access. So it's actually a quick turnaround, ultra high resolution aerial imageries. Also a 360 degrees view, which the insurer members can actually see. So what Imagery's role here is to help automate the whole property damage detection process. So from GIC's risk dashboard, the members can actually access property by property. So they have to actually search their policy's address and then look the two photos, both pre and post-CAT. It's actually quite a manual process if you're actually a claims assessor. You're trying to assess tens of thousands of properties. So Imagery team, they have applied deep learning onto on the imageries and then classify the property damage into different categories. So from no damage to minor and to major structure damage. Here is just a picture of how a roof with light damage it's looking like. And then this one is a major structure damage. So the cloud AI environment can actually detect and classify more than 80,000 properties per hour. So this slide here gives more finer classifications from the claims algorithm. You got the first line there is showing all different levels of roof damage. And then the second line there is actually showing all the impacts of the cyclone, of the hurricane around the building. What I just want to say here is not just purely based on the claims algorithm. There is also some claims expertise, claims adjusters. they actually help to fine-tune the final classifications. So if you look at this one, deep roof damage here, compared to the live roof damage, you need people who has more industry experience, claims experience, in order to say, yes, there is a deep roof one, and also there's a light roof damage. And also to make a call, what sort of pictures or what sort of damage is going to be a total loss. So this is what the insurers will get. Of course, with all the classifications of the property damages, damaged properties, the claims assessors can actually look at each group and then assess the claims according to their guidelines. And you can also get a per risk view for each claim with high resolution of the damage of the property. And you can also get a more holistic aggregated view, say where your particular more damaged area is. I'm coming back to this insurance lever chain here. So what I have just shown here is a use case which trying to improve the efficiency of claims handling process, eventually lower the claim handling cost. Can you think of any other use cases potentially across the lever chain here of how we can make best use of the imageries, both pre and post-CAT event? Okay. So how about those damaged property imageries with ultra high resolutions? All the insights eventually can give you a lot more extra details of what sort of building will receive what sort of damage under what intensity. It'll help with the building resilience, the risk mitigation. And your CAT model on the vulnerability curve, the extra data will definitely validate your model. So on the underwriting side, you can eventually make use of the pre-CAT aerial imageries, help with validated data that you actually collect from your customers, and also improve the accuracy of your pricing and risk assessment. Eventually, the extra insights on what sort of damage with what sort of property can also help you to decide whether there's a particular area or particular segment of the property, the risks that you do not want to write in. So there is plenty of use cases that the imageries, the raw data can be actually applied on. The second case here is around scenario analysis. Scenario analysis is not a new concept in the actuarial world. Maybe can I just get a quick show of hands, anyone here who has actually done any form of analysis using scenarios? Yeah, okay, so you all know what I'm talking about. For the ones who haven't had a chance to do it yet, scenario analysis is a good way of measuring exposure concentration risk. It's required by APRA, and ICAP is a good way of assisting the capital target, setting up the capital targets, and also testing the adequacy of your CAT reinsurance limit. It's a way of quantifying your CAT loss potential and manage your CAT exposure. So the scenario here that I'm using is actually an event that is similar to Cyclone Debbie, but running down further south through Brisbane area. So you all remember Cyclone Debbie? Back in 2017 March, a tropical cyclone category 4 running through north of Queensland, running through Airlie Beach across the Whitsundays. The impact to the insurance industry was 1.8 billion. Part of a large component of this cyclone is that one of the main reasons they bring such an impact is also flooding, the heavy rain that it brought, which caused major flooding across the inland area. This is a map which is created by my colleague who is a geospatial expert. It shows the two cyclone tracks here. So you see up at the north here, that's the historical cyclone Debbie. The one down here, that's our hypothetical scenario. So this the legend here, which shows different scale from both the US and Australia BOM scale. The color here, of course, it shows the wind speed when it first made landfall. It reaches its highest wind speed. For Cyclone Debbie, there was a category 4 according to BOM, which is over 160 kilometers per hour. The one that further south, this is our scenario event footprint, which is sort of making landfall through Brisbane area, which has higher population. And that's sort of the main reason of it, because it's more population, more impact. And with the effect of climate change, even it's not impossible for an event such as Cyclone Debbie running down further south, even though the chance is low. So once you're happy with your scenario event footprint, you actually overlay your exposure on the top of it, and then applying the vulnerability curve to each of the property. And from there, you calculate the estimated loss for each property sustained from the cyclone. This map shows the distribution of the properties losses that are impacted in our scenario. So as you can actually see, so the darker the color, the higher the severity. So when the cyclone first made landfall, that's when the wind speed reaches its maximum. As the wind speed sort of slows down as you go inland, the color sort of fades away. But the vulnerability of a house is not just a function of wind speed. It's also a combination of other factors like year of construction, the distance to coast, the topography of surrounding the house. So that's why you see a bunch of houses, the properties here, even though they're in the same wind speed zone, the losses that they sustained from the cyclone is actually different, as you see in different color. And that's why location intelligence about individual buildings attributes actually will definitely help, and it's actually material in order to estimate the final sustained losses. So this one, so Debbie, there's a large component of flood component in Cyclone Debbie. So to sort of simulate the same type of event, Cyclone Debbie, we try to model the secondary peril, which is a flood-induced, the cyclone-induced flood. So this is a map of the inundation depths. So the darker the color, the higher the inundation. Flood is hard to model, let alone you're trying to model cyclone-induced flood. So what we have done here is we have actually used public available flood mapping data sets. We make a call, say how severe would the flood be following this cyclone event, and then we overlay it onto the exposure that we're interested. So there you go. That's the inundation map, and you can apply the flood vulnerability curve for each property, and then to calculate what's the overall flood losses for this event. Benefits of scenario. Of course, I don't really have to stress out how beneficial it is. It's easy to understand. It's board friendly. It's flexible. You don't have to just make a cyclone. You can make any other scenarios you want. It's in line with APRA's expectations. So I think it's something that the industry should be doing more of. All right, I'm just going to finish with this final slide. So what does it really mean, location intelligence? Ability to generate risk and customer insights that ties to the location. Why does it matter? Increasing the knowledge on the risk and customers lead to better risk assessment and management. Thank you. Sorry for the husky voices again.